Nations and Security, Asia Chapter 2025, or as we fondly call it, TEAS Asia 2025. I am Aparna, and it's an absolute pleasure to moderate today's online session. This international conference is jointly organized by the Banking Academy of Vietnam, Hanoi, Vietnam, and Apex University, Jaipur, India, supported by Shree Universe College, Jaipur, and managed by KK Consultancy Services, India. This year, we received an overwhelming response with over 400 paper submissions from across the globe after filtering out AI-generated and plagiarized content and a rigorous peer review process by our expert panel. Only the top 80 papers were selected for presentation. Based on their performance and the recommendations of our session chairs, these selected papers will be published by Springer Nature. Yesterday, on the 29th October, the day one of the conference, we had an incredible series of keynotes, paper presentation, award ceremony, and the discussion that truly embodied the spirit of innovation and inclusivity offline in Vietnam. As we step into day two, we carry forward the same enthusiasm, ready to dive deeper into thought-provoking sessions and interactive presentations that will continue to shape the future of intelligent systems and digital security. With that, I'm pleased to introduce our session chairs for this segment. Session chair one, that is Navneet Sharma, sir, the Associate Professor, Department of Computer Science, IIS Jaipur. Sir, we welcome you. Would you like to share some of the opening remarks?
Am I audible to all of you?
Yes, sir.
Go ahead.
Okay, moving to the second session chair, that is Vijeta Kumawat ma'am, the professor and head of Department of Computer Science, JECRC Foundation, Jaipur. Ma'am, we welcome you here. Would you like to share some of the opening remarks?
Yeah, good afternoon, everyone. Thank you, Aparna, for introducing me, and thank you for inviting me as a session chair for this conference. And I would like to thanks to the convener of this conference that they give us the chance to moderate to conduct a session as a judge, as a session chair. So always I thanks to you. And I would like to thanks and appreciate to all the participants who are presenting their papers. The best wishes from my side for presentations and their research works. Thank you. Thank you again.
Thank you so much, ma'am. So before we proceed further, I would like to share a few important instructions for all the paper presenters to ensure a smooth and timely session. First, each presenter has 7 to 8 minutes. Please stay within the time limit. Second, briefly cover your research, context, objectives, methodology, key findings, and conclusion. Third, a short Q&A session may follow your talk of about 1 to 2 minutes. Keep your responses brief and focused. Fourth, keep your mic muted when not speaking. And the last one, stay for the full session to support the fellow presenters. So with the kind permission of the session chair, ma'am and sir, can we begin the session?
Yes, please. You may start the session.
Yes, sir. And ma'am, can I get the response from your side as well? Okay, so we'll be starting the session. So now we shall now proceed with the paper presentations, and I would like to invite our first presenter for the day, presenting the paper titled AI-driven near real-time event processing for intelligent risk detection and operational decision making, a multi-industry framework under the code 431. I would like to call upon Ms. Shilpi Yadav to present the paper.
Thanks, Aparna. Thank you for the introduction, and thank you, Professor Vijeta and Professor Navneet, for giving us this chance to present our paper. I'll just right away share my screen. I'm not sure whether you are sharing your screen, or shall I go ahead and share my screen, Aparna?
Ma'am, you can share your screen from your side.
Thank you. Okay. Can you see my screen? Can you?
Yes, ma'am.
Just a minute, let me. Is it coming, the full one? I just. Yeah. So I have my co-author also here with me, Mr. Shrikant, in the conference here too. We are going to present a topic which is AI-driven near real-time event processing for intelligent risk detection and operational decision making. Let's start with simple example or reality. Like every industry when we are dealing with every domain, they're drowning in real-time data. There's massive surge in real-time access, real-time information across industries. Banks, they process billions of transactions every second. School, they collect learning data from thousands of students. Retailers, they track inventory, and insurers monitors all the IoT sensors data. But all are happening all at once. So what is the problem which we are facing here? They are more system, they are even the advanced ones like Kafka and Spark, they can move data fast, but they don't adapt or comply intelligently. They're very good at speed, but not at trust. So what we are suggesting is to build a universal AI-driven streaming structure that brings together edge computing, your real-time interference, and automated compliance under one roof. So what is the result? What we expect, what we got is an adaptive system that thinks as fast as it can process, and one that can legally, ethically, and intelligently make decisions across all sectors, across all domains. When we began this research, we just had one simple question. Can we create a single unified AI framework that works everywhere, across every industry without breaking compliance or performance? To make that possible, we defined 3 different goals. First, we wanted to build a universal architecture, one flexible enough, which can handle any kind of data stream, from banking transactions to classroom interactions. And secondly, we wanted to make it AI borderless, means adapt to any countries, adapt to any region, regulation, or industries. That means the AI model, which is trained in finance, could be used in healthcare or retail, while still following the compliance rule. And third, we wanted to establish a cross-domain benchmark standard that measure not just speed and accuracy, but also fairness and transparency. So these 3 objectives shape the heart of our work, a truly intelligent and ethical AI streaming system. Before we started our framework, we studied how real-time systems work across different industries. And what we found was silo solution, like patchwork or solution, not a unified ecosystem. Platforms like Kafka, Spark, Flame, they're very powerful data throughput, but they lack built-in intelligence or adaptability or the compliance. So each industry had its own powerful tool, but they have built its own isolated version. So in finance, you will find low latency trading system. They're very super fast, but not transferable. Like insurance, they still run on legacy systems. They have very limited automation. Same thing with education. They uses learning analytics, but they are under very strict privacy constraint. And retailers, they have great personalization engine, but they hardly compliant. They're hardly compliant. So what we found is every domain is solving the same problem, but they're solving it separately in silos. That's what the research tab, what we addressed, that what we needed is a unified approach, which is compliance-aware AI streaming framework that can also learn, adapt, and operate responsibly. How does our system, what we have come up with, actually works? Think of it as a highway of data where every vehicle is a data stream, where AI acts as your traffic controller, ensuring everything moves safely, fast, and within rules. So first is our data ingestion module, which pulls information from different data sources, your structure, your unstructured data, your transactions, sensors, learning data, retail logs, everything, and it standardizes them in a real time. Then we have edge processing layer, where computation happens close to data source. That's how we achieve sub 5 millisecond latency. It is processing information instantly, even without relying on cloud servers. Then AI-driven stream engine, which is the brain of this whole architecture. It continuously learns, it adapts, it balances workloads, it optimizes performance under every heavy load. And the decision engine, it translates insights into actions. Means wherever there is a fraud which is happening or anything which is updating a learning recommendation, it immediately tells you. It is all built in with the traceability so that you can track it too. And lastly, the compliance. It literally acts as your watchdog. Means it is making sure every decision you're making aligns with your GDPR, your SOX, every compliance rule. One of the most exciting thing about this is how it adapts to each industry. It is almost like a multilingual AI which talks in every language to every domain. So in EdTech, in education, it connects to learning platforms and assessment tools, analyzing student behavior in real time, and does so safely using your alliance with compliance. Then your insurance. It processes IoT sensor data and claims information to detect fraudulent activity almost instantly, all while managing compliance across multiple countries. Then finance. Speed is everything in finance. Your system supports sub 10 millisecond trading and fraud detection. And in retail, it merges customer behavior and supply chain analytics to deliver personalized recommendation and also dynamic pricing, fully respecting with privacy regulations. So the beauty of this architecture is that the core never changes. Only the adoption layer, whatever it is, it does it. That's how the single framework becomes a universal backbone for real-time data. Let's talk about what happens within the system. So first of all, every model is containerized. Means you can simply, it is packaged with everything. Your configuration from dependency to environment configuration, it can run everywhere, anywhere. You just have to deploy it. It can be done on cloud, on-prem, or even at the edge. Then the system automatically handles the retraining, also testing and everything. Whenever there is a new data pattern appears, let's say if there is a fraud behavior evolving it, or a student learning trend shift, it automatically learns and adapts by its own. There is no manual tuning which is needed here. Then there is cross adaptability. Like it's kind of shared library which we are considering, so that every country they talk in the same domain. So the result is that AI pipeline that almost always working, always learning, always optimizing and delivering consistent, explainable result.
Sorry to interrupt, ma'am. Ma'am, we are running short of time. Can you please conclude?
I'll just, quickly. Okay, so next is our compliance. Like it always monitors, like every part of the framework, we have this compliance layer that ensures every decision is with your GDPR, your SOX, all the rules are there, where it can explain why the tracking has happened. Everything is open in here. There's certain industry use cases when we found it, we see that there was over 99% accuracy for fraud detection. And it don't just react. It doesn't just react. It predicts and learn from every event. The same system, it scans IoT data and claim histories to flag unusual pattern. Same thing for education. It monitors students' activity, it quiz results, and personal learning centers. So there is 35 to 60% engagement rise in there. Every industry has its own. We have listed down everything in the paper when we broke it up. When we just talk about what does the system, the technology behind it makes it work. Like at the edge, we use this NVIDIA Jetson, then we have Google Coral, that allows AI interference to happen right where the data is generated, whether it's hospital sensor or the retail checkout. Then we have the orchestration. We use Docker and Kubernetes for auto scaling, for self-healing. For security, we are using the federated learning in defense of privacy and zero trust access. And finally, the system adapts caching and event ordering to keep result consistent across global needs. And what we found, like after we did all this, is in healthcare, the system cuts responses by almost like 95%. In finance, throughput double, almost like a 200% gain, which we saw, while the fraud detection accuracy climbed up to 99.4%. And education saw a 42% increase in course rate completion. So when we look at all these results, what do we see? A multi-industry AI streaming framework, which is unifying everything, like edge computing, real-time interference, and compliance. We are achieving great latency reduction, compliance automation increases. But what if without challenges? No. Healthcare, they require regulatory certification, where they're very strict in data privacy. Finance also, it is because speed is everything in finance. The millisecond matters. Same thing for education. You keep everything, the trends keep on changing, and you need it to be compliant. But how did it help? Really? So how does it help? But the synergy between them was what made it very effective. Privacy lessons from healthcare improved your education industry, and automation patterns for finance, health, insurance. That's how we saw. But there's a lot more to do. What we are seeing is like, we're only at the beginning. The next phase will bring self-healing AI or federating learning AI, quantum ready. But that is something which we can decide, which we can do for the future work. And with this, I conclude my presentation for this. Thank you so much. And sorry for taking a little bit more time than expected.
Thank you so much, ma'am. We are open to questions, ma'am. If there are any questions, you can proceed.
Yeah. Your presentation is very nice, Shree.
Thank you.
And
Okay.
I have a question that
Sure.
you have mentioned some database in your presentation.
What is it, ma'am? Data?
From where you took your database?
So these are all, okay, so these are not the real-time data. We all took the Kaggle data set, which are available in the Google, and we try to analyze using that.
Okay. And what about the security point of view? What tools you have used for the security of the data?
So it is about so in Europe, we have those GDPR, and like every country, they have different compliance, which we use. So SOX compliance is different than in Europe, when we deal with SPI, PI data, we have those GDPR compliance. So those laws, whatever rules and all were there, we implemented those when we were considering it.
Okay, fine. Your
Am I audible?
presentation is good. Yeah.
Yes, Shilpi, I have one question. Am I
Yes,
audible?
Yes, sir, you're audible.
Okay. Can you show me your second last slide? The
Okay.
experimental findings.
1 minute. Let me share my screen again. Can you see my screen, sir?
Yes.
Yeah.
So can you elaborate this thing, whether latency reduction and the throughput gains? It is plus 30, 132, 200 plus.
So latency is
Can you?
how fast you can actually predict. Like as soon as anything happened, how effective were your trigger response was. Anything
What is
happened in
your
the hospital.
specific contribution towards this framework?
I'm sorry, what is it, sir?
What is your specific contribution towards this framework designing?
So, okay, so to be very frank, I did not use any real-time data. I had to use all whatever data set available in the Kaggle data set or in the Google or everything. Based on that, we come up with that framework. We came up with this number. We conducted using tests using those data set.
So
Is
what is
that
the
the question you're
authenticity of
asking?
this data?
Yeah, so that is okay. Those data set are all available. Like they are all in the public domain.
Okay.
If you're asking about the real time, yeah, those access we did not have, but whatever were available in the real time, whatever available in the Google dataset, which says, okay, this can be used. And we also checked on previous papers, wherever they have such collection of data. Then we came up with this metrics.
Okay. Thank you so much.
Thank you so much, ma'am and sir. So further, moving to the second paper title, that is Urban Air AQI Prediction, Capacity Matched is Ensembles with Diagnostic Interpretability and Deployment Concerns. Under the paper ID 380, I would like to call upon Srinivas Gopalan, sir. Srinivas Gopalan, sir, are you there?
Good afternoon. Hello.
Good afternoon, sir. You can continue with your presentation.
Good afternoon, everyone. Today, I will be presenting on our work, Air Quality Index Prediction using ensemble learning techniques. This work addresses not only predictive performance, but also interpretability and practical deployment. Here is the agenda for this presentation. Introduction to Air Quality Index and motivation. Literature review highlighting the past work or methodology, including models and data pre-processing. Experimental setup and evaluation metrics, result and analysis with interpretability, tools like SHAP, limitations and future scope, and conclusion. Air quality index is a standardized measure used to communicate how polluted the air is currently or forecasted to become. In India, the Central Pollution Control Board defines the air quality as a composite number derived from key pollutants such as PM 2.5, PM 10, nitrous oxide, and carbon monoxide, etc. While air quality index monitoring exists, it is often reactive and not predictive. Models that can anticipate pollution spikes, especially events like major polluting triggering events like wildfires or local festivals or unexpected rain, are crucial. Moreover, previous models lack transparency, making them hard to trust. We wanted to design a system that is accurate, interpretable, and deployable. The aim was to use a historical air quality index data and weather conditions to build a future-facing air quality index forecast system. Earlier studies used deep learning models like LSTMs to predict the ozone levels. While these achieved good performance, they functioned as black boxes. Other researchers such as XGBoost based models focused on a single pollutant and ignored the bigger picture. Additionally, many studies did not combine meteorological normalization with forecasting. Our work fills this gap by incorporating explainable machine learning for AQI forecasting, not just pollutant specific. Here is the workflow summary. Our end-to-end pipeline included reading and cleaning CPCB data, imputing missing values and filtering inconsistent errors, splitting data, training individual models, combining the predictions to a stacking regressor, interpreting outputs using SHAP value, evaluating performance and visualizing the results. This structured workflow ensured the model was not only accurate, but also transparent and ready for real-world forecasting. Now let's talk about the dataset. Our dataset was sourced from the Central Pollution Control Board, covering daily air quality data across 26 cities in India from 2015 to 2020. It includes various pollutant concentrations and corresponding AQI values. During pre-processing, we encountered missing values for some pollutants. To handle this, We removed columns with too many missing entries. For others, we filled in the missing values using statistical methods like mean or median based on city-specific distributions. This ensured data completeness without distorting pollution trends. Why does this matter? If missing data isn't addressed properly, the model could learn incorrect patterns, leading to unreliable predictions. Clean and consistent data was crucial for building a model that reflects real-world air quality behavior. The methodologies and testings used. I've used linear regressive, decision tree, random forest, and XGBoost, and then stacked all the models together. Let's find out why each model. Linear regression assumes a straight line relation and is easy to interpret, but it is too complex for complex patterns. Decision trees split data by feature thresholds, but can easily overfit. Random forests reduce overfitting by averaging many trees. Gradient boosting builds models sequentially to correct past errors, often achieving higher accuracy. The stacking regressor combines all these using their predictions as inputs to a final model. It is an ensemble model that combines multiple base models. Each of these models predicts an AQI, and then a meta-learner combines their outputs to make the final prediction. This boosts performance significantly by aggregating model strengths. Experimental setup. We trained on 80% of the data set and tested on the 20%. To test the performance, we used metrics such as R-square score. It measures how well the predictions was. The higher is better. Our was 0.9523. Then mean absolute error. It shows the average magnitude of error. The lower is better. Then RMSE, root mean speed error. It penalizes large errors more than mean absolute error. Then we used Shapley additive explanations to explain how each feature contributed to the model's prediction. It assigns contribution values to every input feature for a particular prediction, making the model transparent.
Sorry to interrupt, sir. Can you conclude fast?
Yeah. Why ensemble learning? Overfitting happens when a model memorizes the training data and performs poorly on unseen data. Underfitting occurs when a model is too simple to catch the pattern. Stacking balances both by reducing the variance through averaging and bias by incorporating multiple learning perspectives. Now let's look at the heat map first. It shows the Spearman correlation between pollutions. PM 2.5 and PM10 have the highest correlation with 0.92, confirming their dominance. Benzene, toluene, and xylene had moderate to low correlation, which is expected as they fluctuate differently and are localized. Now the scatter plot. It compares the predicted versus observed air quality index. The tight clustering around the diagonal line indicates that our model accurately tracks real-world air quality index. Few outliers exist, like during festivals or rain events, which are not marked explicitly in the data. Still, the model captures the overall trend with precision. The following table summarizes the held out test set performance of all models evaluated. The stacking regressors gives us the best values with R square of 0.9523 and RMSE of 19.93 and MAE of 13.49. And here the N test refers to the number of tests that we performed to achieve this result. Our stacking regressor showed the best performance among all the linear models. Now coming to future works and limitations. Limitations include lack of event tagging. Our model doesn't know if major pollutant triggering event such as wildfires or local festivals are happening or if it rained. That context would make predictions even better. And also it doesn't currently adapt to the concept drift. Changes in pollution behave over time. And in the future, we are planning to add events such as rainfall, adding rainfall in as a feature. As we know, rainfall reduces the air quality pollution after. So, and then tagging events such as crop burning and major pollutant triggering events like wildfires or local festivals. In conclusion, our ensemble-based air quality index prediction system balances accuracy and interpretability. It uses tagging to combine various learners and applies SHAP for transparency. Compared to black box deep learning models, ours is open source, practical, and built for real-world use. With planned enhancements like event tagging and adaptive updates, this system could serve as a blueprint for urban air quality index forecasting tools nationwide. Thank you.
Thank you so much, sir, for that wonderful presentation. Now we are open to questions. Ma'am, sir, if you have any question.
No question from my side.
There is no question from my side, but I just want to give a suggestion to Srinivasa ji that we have seen your all the slides, your presentation, which is very presentation is your very good, but some of the slides where you have mentioned the text, which is not understandable. I don't know why. Maybe my actually I have connected on my phone, so maybe I am not unable to read that content. But overall, your presentation is good.
Thank you, ma'am.
Thank you so much, ma'am and sir. So further, we proceed to the third paper that under the paper title Hybrid Ensemble Approach for Predicting 30-Day Hospital Readmission under the paper ID 422, for which I would like to call upon Lalit Kumar sir to present the paper. Lalit Kumar sir, are you there?
Ma'am, this side Suman Char is there.
Okay.
I will present the paper. Okay.
Yes, ma'am.
There
Sure.
are some. Okay. I hope my screen is visible to everyone.
Yes, ma'am.
And I'm audible. Okay. Good evening to everyone. And my paper ID is the hybrid and sensible approach for the prediction 30-day hospital readmission.
You are not audible.
Am I audible?
Suman ma'am. Yes, now you are audible.
Okay, sir. Okay. Then actually means the aim of this paper is to find the objective like this. Whenever a patient is admitted in the again, then if they are visited surprisingly within 30 days, then it will be costly to the hospital, and it burden to the healthcare system and all patients outcome means it will be effect to the hospital's outcomes also. And I am trying to find out the that how many patients will be readmitted in the 30 days. If hospitals will be get this in advance, then they can arrange themselves, and patients also maybe ensure that. And I find, and I have worked for this for using a data set that I have taken from the Kaggle, and data set name is the breast cancer Wisconsin diagnostic data set. And the 30 days hospital readmission remain a Chernobyl concern, increasing cost, negativity impact patients' outcome. Traditional single model approach often fail to the capture complex pattern in the multidimensional clinic data. In this, I have taken the 30-day clinic data, and there I have in the dataset there is a 30 features and 569 records was there. And before going for this, I have taken the challenges, or I have read out the some papers from there. I have got the idea, and these are the some papers and methodologies have been used on the different data set, and the key finding of that papers. Like AI, Alvin has used a data set general internal medicine mission data, and he has used the gradient boosting and the read logistic regression, and he is finding the AOC 0.89, sorry 89, emphasized hybrid methods. Second, Sharda and ET also have worked on the hospital read admissions, and they have technique the ensemble models and including XC boost, and they improve recall versus base ML model. Then next is the ICU readmissions, and they are also used to technology or methodologies XBoost and the Sharp. They have used the predictability of the 0.93. Rajkumar et all the electronic health, they have used the deep learning and the logistic regression. They improve the sensitivity but reduce the interpretability. Like this means ki some people have worked but already, and some people also tackle the problem of data imbalance in medicine claim data specific reaching 92% accuracy level in the demonstrate. Critical role of the classes distribution management in their specific article, Rajkumar's and all compared the deep learning methodology that I have discussed in previous table, and like this all these I have explained in the paragraph. Then this is my methodology that what I have done. Our prediction framework leverage is taking assemble combining diverse machine learning algorithm for robust hospital readmission risk prediction. The technique applied as two-level model. Level 0 base model have the logistic regression, random forest, and the gradient boost and the spot vector machine. Means four models I have used at the base level 0. Logistic linear is LR is used for the linear relationship and offer high interpretability, and RF is for decision making and decision tree robust to the overfitting and the effectiveness for the non-linear partner. Gradient boosting sequentially build model correcting previous errors, excellence in the capturing subtle data pattern, and sport vector machines maximize margin separate effectiveness in the high dimension non-linear space. Then next on level 1, meta model is used, that is a logistic regression that integrate and assign optimal weight to the base model.
Ma'am, please move on to, sorry to interrupt you. Please move on to your experimental work.
Okay, sir. Okay, sir. This is the my proposed hybrid model that I made, and there I have taken two levels, level 1 and level 2. In previous level that I have already told you that different machine learning models I've used, and then combine next level 1 I have combined all the results and the reduce the overfitting and finally predict the hospital readmissions risk. And this is the evaluation of the predictions model in
How it is different from the existing model?
Okay. Sir, they are not using the two levels. They are combining. They are making the hybrid. But I have make hybrid with the combining at the two levels. Means first level I am combining all. Mostly models are working on the combine two models, combine three models, combine four model. I have firstly combined all four models, find the output of that. Then I have again take the input of the output of that models and put in the next model, and then find the output. This is the difference from the another. I work on the level wise.
Okay. Please continue.
Okay, sir. And this is the hybrid stack. That's why it's called the hybrid stacking framework. Again, level 1, I have used the base models, and again, meta learning is used at the level 1. Their logistic regression meta learning integrate base model, predictions, assignment, optimal way to balance bias and the variations. And after that, after the second level, final prediction, stack, assemble, leverage, complementary strength of the linear and non-linear model for superior accuracy and the robustness. Then this is the data pipelining. It's working. This is the same pre-processing, standardization, state files split that every model we have done same work I have done. Then architecture, same again, four models I have used firstly. Then this is my result. that I have implement. That accuracy I find the 98.3, and the precision is 100%, and recall is the 95.2, and F1 score is 97. And this is the comparison of the performance with the another model. If I using the single model like logistic
Sorry to
regression.
interrupt, ma'am. Please conclude fast.
I'm concluding. Okay, ma'am. And this is the my final. Okay, final slide, and this means I am. This is the comparison. You can see that different models have different results, and my model hybrid stacking ensembles have increase the overall result in comparison on all level: accuracy, precision, recall, F1 score, and AUC. And then in future direction, we can say that if this will be fruitfully to all, then every hospital can use this type of the models, and they from this they can guess that how many patients will be readmit in the hospital, and they can arrange accordingly. This is the my work. And again, our hybrid stacking assembly achieved 93.3 accuracy and the 0.993 AUC, demonstrating the transformating potential of the assembly based prediction modeling in supporting clinical decision making. Means it's really helpful the decision making in the hospital. Basically my basic idea is to must find a model like to help the hospitals to take the decision for readmissions of the patients. And thank you. This is from my side. Yes, ma'am.
Thank you so much, Suman ma'am.
Yes, sir.
No question from my side. Vijeta ma'am, if you have any query. Okay, we can move for the next participant.
Okay, thank you so much, sir. Okay.
Aparna ji, we can move for the next participant.
Hello.
Yes, Aparna ji, we can move for the next participant.
Yes, sir. Sorry, there was a network challenge. So moving to the next paper title, that is Fusion-Based Multimodal Deep Learning Framework for Breast Cancer Classification under the paper ID 434, and I would like to call Vibhor Gupta for the same.
Thank you, Aparna ma'am. Firstly, my side, Vibhor Gupta, working as a research scholar in Maharishi Markandeya University, Molana. I am warm welcome to our session chair, Professor Navneet sir and Professor Vijeta ma'am. Shall I start my presentation here?
Yes, go ahead, please.
Thank you, sir. So everyone visible to screen fusion-based multimodal?
Yes, the screen
Yes,
is
sir.
visible.
The screen is visible.
Shall I start? Fusion-based multimodal.
Maximize it.
Yes, sir.
Maximize your presentation. And
Just a
slide show.
second. Sir, it's all right, sir?
Yes.
Okay, sir. Myself, Vibhor Gupta, working as a research scholar in Maharishi Markandeya University, Molana. My paper ID is 434. Firstly, I developed a model, fusion-based multimodal deep learning model framework for the breast cancer classification. For the accurate prediction, in the classification we have two things in the cancer: the benign and the malignant. Benign means the person is a healthy set, and malignant means the person have a cancerous detection. In this content, we have an introduction, literature review, proposed work, algorithm, data sets, performance metrics, result and conclusions, and the reference. Firstly, before going to the deep learning model, in the first we have to see that in the traditional model, that we have to use the traditional model are the time consuming model. Then we proceed for the machine learning model. In the machine learning model, they have two problems: the overfitting problems and the lack of generalization and special context problem. Then the deep learning model are to be introduced. They have a different deep learning models are available in this my paper presentation. For the better classification of the cancer detection, we have used a ResNet, DenseNet, and the inspection ResNet version 2. These are the literature review. This one is my proposed framework. In the proposed framework, firstly, we have to check the GPU system is available or not. When the GPU system is available, firstly, we have to difference between the GPU and the CPU. In the GPU, we have to less the processing time, but in the CPU, when the number of images are to be loaded and conclude, they have taken some time. So then we have to use the GPU system. In the GPU system, firstly, we have to load the images. Then we have to resize the image 24 to 24 into 24 and apply the Clag method and the augmentation, and then we have to create a fusion based. In the fusion based, we have three models: NestNet Mobile, DenseNet Mobile, and Inspection ResNet. With the help of these three models, we have to get the global. Hello. Yes. In the individual model, we have to get the global average pool. With the help of global average pool, we have to reduce the dimensions, and on the basis of dimension, we have concatenate all the features and applied to the dense layer and trained our model. In this mechanism, we have taking a training data set 70% and testing data set is 30%. And with the help of this is my algorithm. In this algorithm, we have to compute the losses with the help of. Hello. Aparna ma'am, can you hear me?
Others, please
Yes,
mute yourself. Yes, Vibhor, please continue.
In this my algorithm, we have to compute the losses with the help of BCE, means binary cross entropy. Entropy mean information. On the basis of this, we have to taking a 70% of training data set and 30% of testing data set. And in this my deep learning model, we have to improve the model generalization with the help of data augmentation and reduce the overfitting. And taking my data from the Kegel breast cancer patient MRI data set, which contain the 480 grayscale MRI images. The next one, we have a performance metrics: recall, F1 score, accuracy, and precision. In all the four metrics, this is the result of confusion metrics. Confusion metrics are based on true positive, true negative, false positive, and false negative. On the basis of this, we can conclude the result. We have taken a 3 base paper, 17, 18, and 19. All these three person have conclude the accuracy, precision, recall, and FN scores individually. In my proposed fusion-based model, my accuracy is better than the above three models for the prediction of breast cancer detection easily. In this framework, we have a little. We have to capture the more fine-grained morphological details and diagnose the cancer detection easily and minimize the redundancy between some models. In the previous modality models are based on single modality model, but in my fusion based, we have used a multiple model deep learning techniques, a framework to use for the efficiently detection of the breast cancer. These are the main advantage of this paper. These are the reference. I have taken 19 papers for studying about the basic in 17, 18, and 19 papers. The number of the researcher have taken a efficient net old version. In my technique, I have taken a DenseNet 201, the latest version, NestNet Mobile, the latest one, and the inspection RESTnet v2 version. In the previous, they have taken the efficient 150, 50, and these have to give the less result from my result. This is the result scenario. These are the techniques for 17, 18, and 19 papers. Accuracy level from my side with the help of 3 is better than all the 3 papers. Precision is or better than all 3 papers. Recalls and F1s. We have taken only these 4 performance metrics to evaluate. We have to compare these 3 base papers and develop a better framework or better algorithm to efficiently classify the cancer detection. From my side, presentation is any questions from your side?
What was the selection criteria of different algorithms and different models you have chosen for this
Sir,
experimental process?
first of all, sir, firstly, we have to study a number of research papers. In the research paper number 17, they have taken a efficient network 50, efficient network 150. They have a different version of the deep learning model. In the deep learning model, we have to check their accuracy level, their precision level are very low. They have used a old deep learning model. But in my deep learning model, we have to take on the latest version, dense 201 and inspection.
In your opinion, which model is better for the comparison of the your proposed model and the existing model?
Sir, my opinion, sir, I have taken the combination of both of 3-1. Firstly, I have individually tested individually the dense model and the inspection net and nest net. We have to choose the inspection net, sir.
Okay, thank you.
Thank you, sir.
Thank you so much, sir and ma'am. So further, we'll be moving to the next paper under the paper title, A Comprehensive Review of Secure Boot Architecture in RISC, V and ARM Embedded Systems. So for that, I'll be calling Soham Lotlikar, sir. Please continue with the presentation.
Hello, hi. So good afternoon, everyone. I'll just share my screen 1 second. Right, so I hope you can see your screen.
Yes, sir.
Okay, perfect. So good afternoon, everyone. I'm Soham Lotlikar, an undergraduate EXCC student, and I'm presenting our work titled A Comprehensive Review of Secure Boot Architecture of RISC-V and ARM Embedded Systems. This work was carried out under the guidance of Dr. Poonam Kadam at SVKM's Dwarkadas D. Sangvi College of Engineering. So we learn why this is important. So today, nearly every smart system, from medical implants and autonomous vehicles to industrial controllers and defense electronics, depend on embedded processors. These systems often operate unattended at the edge and are vulnerable to firmware tampering and hardware-level attacks. The first instruction that runs after the power-up decides whether the system can be trusted, and that's where secure boot comes in. It ensures that its authentic, untampered firmware is allowed to execute. However, current secure boot solutions are fragmented. Open source architectures like RISC-V lack built-in frameworks, while commercial ones like ARM Trust Zone face scalability and physical security limitations. Our paper addresses this gap, a comprehensive comparative review, systematically analyzing secure boot architectures, both ecosystems, to identify their strengths, weaknesses, and the path towards hybrid, self-healing, intelligent secure boot designs. So before going further, I'd like to emphasize that our review adopts rigorous system literature approach, synthesizing more than 35 recent research works. This ensures an unbiased and comprehensive comparison of secure boot trends and innovation in both RISC-V and ARM ecosystems. Secure boot establishes a chain of trust. Each stage verifies the next before execution. Without it, attackers can just inject malicious code directly into the flash or memory. RISC-V, being an open and flexible, lacks a built-in secure boot framework and relies on add-on modules such as PUFs and TPMs. In contrast, ARM Trust Zone provides hardware isolations but remains vulnerable to physical memory probing and rich OS exploits. These gaps motivate the need for hybrid secure boot models and balance openness, performance, and resilience. The objective of this review is fourfold. First, to analyze secure boot practices implemented on RISC-V and ARM architectures, focusing particularly on embedded and lightweight systems. Second, to examine key implementation aspects, including cryptographic primitives such as SHA, AES, ECDSA, key management mechanisms like PUF and TPMs, and isolation frameworks like Trust Zone and Cache Lock-in. Third, to compare trade-offs in performance, security, and flexibility across that models, firmware update processes, and boot time validation. Finally, to identify the existing limitations such as lack of runtime protection and or recovery, and outline potential hybrid and self-healing directions. Together, these objectives define a systematic literature review that bridges open and commercial secure boot research. Secure boot depends on strong hardware roots of trust. Physical unclonable functions, PUFs, derive unique cryptographic keys from microscopic devices variations, removing the need for stored keys and preventing cloning attacks. The TPMs, which are trusted platform modules, are dedicated microcontrollers that handle cryptographic operations, measured boot, and key storage, forming a verified root of trust.
So I'm sorry to interrupt you.
Yeah.
Move on to your work, your
Uh,
contribution.
yeah, so basically, right, okay. So what we did was we basically studied other architectures on key management mechanisms, cryptographic primitives, firmware update capabilities, runtime security, cold boot resistance, and implementation complexity, clarifying each design strength and constraints in real world scenarios. So this is what we came to the conclusion with. Is we studied the RISC-V and architectures wherein the lightweight SoC boot design uses a hardware verifier and SHA-3 engine integrated with a PUF-based key manager, achieving extremely low boot times per about 67 microseconds. However, it lacks firmware update support. Coming to the conclusion of what was drawn from this is right. So as threat sophistication increases, the next frontier is intelligent secure boot. Lightweight machine learning agents embedded in the boot chain can continuously monitor firmware behavior for anomalies, enabling real-time trust and evaluation. So these models can predict deviations due to tampering or hardware faults and dynamically adjust verification policies. In open architecture like RISC-V, this can be implemented efficiently within secure enclaves. So what our review recommends several research priorities for the community, which is strengthen the robustness of the PUF and hybrid hardware roots under environmental variations, develop secure, resilient over-the-air firm update protocols, and pursue hardware software co-designs to increase resistance to side channel, cold boot, and tamper attacks. So this is basically what we were trying. So this was a review paper about the secure booting mechanisms of RISC-V and ARM architecture. So if any questions.
Thank you, sir.
Yeah.
If you have any questions, sir, please proceed.
Not from my side.
Okay, ma'am, do
No
you have
question
any
from
questions?
my side. No. Next
Okay.
presentation can start.
Okay, thank you so much, ma'am and sir. So further, the last paper title, that is Rising Infertility Trends, Analyzing Medical, Social and Mental Health Perspectives. Under the paper ID 551, I would like to call Miss Anika Sharma for presenting the paper. Ma'am, are you there? Miss Anika Sharma or VK Srivastav, sir, if you are there. Okay, seeing none, are there any paper presentations left here?
Yes.
Okay, sir, you can proceed with your presentation and please do mention your paper title and paper
Okay.
ID.
Hello, my name is Fahad. Am I audible to everyone?
Yes, yes, you are audible.
Yes, sir.
Yeah, my name is Fahad and I'm from Department of Computer and Cybersecurity, North American University, Texas, USA. So my paper name is a Cybersecurity Focused Risk Assessment Framework for Multi-Party Digital Asset Custody Operation. So basically, this is a paper which combines the management of cybersecurity, which plays the double role on the multi-asset like the cryptocurrency and the digital marketing. My paper ID is 421. So proceed towards the emphasize what's the main purpose of my paper. So basically, the growing importance of the digital assets like Bitcoin and Ethereum, which are the top-notch coins. And the problem of the cryptocurrency is that when the transaction is done of decentralized, so we can't reverse it back, or there is a lot of problems of the transferring. So my paper is basically based on the cryptography, which is the private key, which detects the importance of a digital assets, and we can trace it by using the algorithm which I would be discussing in the further, which is a binary tree algorithm and the revolt protocol. So my goal was to develop a quantitative cybersecurity risk for this paper. So basically, in the abstract part, it's basically I use the attack tree modeling and quantitative risk traces. I have demonstrated through the practical labs in my university level with my professor, Dr. Leon Chun. So we detected algorithm, which is a binary tree modeling, which I connected with the revolt protocol, which is we detect the framework of the cryptocurrency vulnerabilities. Like if I using the machine of the Kali and the window machine, if I detect if the Kali machine is already connected with the IP address of revolt of the window machine, so I can use that revolt protocol, which is a built-in Kali Linux protocol, which I can detect easily by by their wallet address, which give us the HD wallet, which I can trace it and detect the customer wallet address. So basically, the introduction is the same which I have given, that it detects the Bitcoin of the reversionary financial ecosystem. So it is basically based on the cryptographic key management of the comprehensive detection method. And moreover, the framework of the cybersecurity which I have covered, I will be discussing all the three layers which I have used in that. So my work is related to the Bitcoin custody, which I have used the SD wallet, which I have done which I have detected through the revolt protocol by detecting the security mechanism, which I detect by the Kali and the window machine, by getting which we can detect the password by using the built-in Kali methods like the John the Ripper and different tools. Moreover, the methodology which my framework, or which I have proposed the work, which is based on the three scopes. The operational scope. So basically, this is a cycle of three chains: wallet, fund, and termination, which I mentioned earlier. If the wallet is transferred, we can't detect the address of a funds and we can't terminate it. So by using the Rickel protocol, we can help to lower down the risk management in this scenario. Moreover, in the attack tree modeling, it is basically algorithm which gives us the tree algorithms. Like if there is a scenario of yes or no, so we have a option of both scenarios, and or gate. So like one or in the end, one is switched off and another other is on, we can't detect it. But in or if one is open, we can detect it. Moreover, in the quantitative evaluation, we have used the Monte Carlo simulation. This is a chip which is provided us to detect the digital assets, because it needs a lot of power to detect the machines. So it is provided us to detect the Monte Carlo simulation, which is a new chip of the Kali, which is recently uh, provided us in our labs. So what is the implementation in this paper through our evolved protocol? So basically, it gives us the stakeholder, means if I am a customer, it gives us the protocol. Like I'm a customer, I can detect all the custody protocol, like the funds, how much crypto, bitcoins, ethereum, and different coins are based on it, because it works on a three system: PIS, priority, time, and the management, quantitative propagation. Moreover, the result of my key findings is that if I use this revolt propagation, so it gives us the reduction of 35% when I use when we were practically using the in our labs. So it gave us the reduction around 40 to 45, but we cut the 10% because of a loss of a Monte Carlo simulation. So after detecting it gives us 35% of the evaluation. So moreover, during that practical, it gave us the priority timeline of between 0.32, sorry for that, 0.32 and the 0.25. So this was a priority time period during the practical which we perform in the labs. So moreover, my discussion was basically based on the attack tree modeling, the competitive and the revolt protocol, because but for this the Monteiro chip is so much expensive to afford it, but it has the security and cost is too much high in that. So my future work is based basically to try the cryptography with the operational reliability, and also more deep research on the revolt protocol. That's it from my side.
Thank you so much, sir. If there are any questions, we can proceed with that.
Not from my side.
And ma'am, do you have any question? Okay, so are there any paper presentations left?
Hello.
Yes, ma'am.
Yes, I'm Dr. Hemlata Jem from Purnima University. I have also a presentation to be presented. Actually, we submitted the late, so we have talked to Vijay sir.
Okay, sir. Okay.
So please include
Ma'am,
my
totally
presentation
fine.
also. Nikita ma'am will present.
Okay, ma'am. Please do mention your paper title and paper ID. You can continue with your presentation now.
Actually, sir, known about the paper ID. I don't know about the paper ID. So it was submitted late. So I can tell the paper title.
Yeah, you
Oh,
can proceed with that. Thank you.
okay, thank you. Nikita ma'am, you can present the paper and tell the paper title also.
वेट मैम मैं कर रही हूँ 1 मिनट शेयरिंग हो रही है हेलो यार ये पीपीटी शेयर हो रही है बट वो नहीं हो रहा है प्रॉब्लम आ रही है पता
Ma'am, your screen is visible.
Yes, your skin is visible.
मैम
Open it in the
इट्स नॉट
slideshow
मूव
mode.
नेक्स्ट स्लाइड एक्चुअली वेट 1 more second
If we have the permission of the session chairs to present the presentation without the slides, will that be possible? And she'll share the slides through the email to the team.
If she is comfortable with the presentation, oral presentation, she may
Okay.
continue.
Okay. Nikita ma'am, you can start just the oral presentation and share the PDF or the slides with the team itself through email ID. Nikita ma'am, are you there?
Yes, ma'am. Yes, ma'am. Thank you, ma'am. Wait a second. I start my PPT. Sorry to. Good evening, everyone. I am Nikita Sharma from Pune University, Jaipur. I am delighted to present our research title is Generative AI Methods and Application, a detailed review at NICTEAS 2025 in Vietnam. This work basically is a collaboration study with Dr. Ajay Khundeta sir and Dr. Hemlata Jain ma'am. Basically, it is focusing on the latest models, methods, and application of generative AI across various domains. Basically, our overview, our this research paper, this review paper highlight how generative AI has transformed content creation and automation. We focus on fundamental like GAN and LLM model, while also explore hybrid approach like diffusion, GAN, retrieval, augmentation, generation. The goal was to provide a unified uh, comparative analysis of emerging trends and application. Basically, it is a review paper where we include everything related to generative AI. If I am considering the traditional AI or generative AI, there is little bit difference. Like in the traditional AI, we use classification and prediction, but in generative AI, it create content, new data, create new data. And in the traditional AI, we use supervised, semi-supervised, but in the generative AI, we use self-supervised learning. Generative AI basically
Can you
generate
please
new
move on
large
to your
data set and get prediction here. Sorry.
can you move on to your experimental process?
Basically, sir, it is a review paper. Here we explore
So
about the generative AI models.
can you just explain the findings what you find in your review
Okay,
papers?
okay, okay. Here I find like I analysis it's a model GAN generative adversarial network, VAE variational autoencoder, and large language model and diffusion model. In the comparative analysis, I found it that GAN gives accuracy 85%, but here is the unstable data means which data is generated by GAN is unstable, but VA give 80% accuracy and stability is high, better than GAN. Stable, but it gives slower process. In LLM, we get 90% accuracy, stability also high, 88%. Here we generate balance and general output. And diffusion model, which we use these days, it is a basically use a advanced version of GAN, we can say. It gives 92% accuracy and stability also high, 95%. It gave high quality data in the images also and in the text also. Basically, this is my result.
What were those your reference papers, ma'am, for this
So-
review study?
Sorry.
पेपर्स कौन से आपने लिए हैं रिव्यू करने के लिए? पेपर कौन से
मैम
कंसिडर किए हैं पेपर्स स्टडी
मैंने
के लिए?
मैम IEEE के लिए हैं, BCI के हैं एंड विले के भी हैं. ये सभी IEEE ट्रांजेक्शन ऑन पैटर्न ये सभी लिए हैं गैन के 2020 से 25 के बीच में लिए हैं मैम.
लेटेस्ट पेपर यू हैव
यस
सेलेक्ट फॉर दिस स्टडी, राइट?
यस मैम यस मैम.
ओके, ओके.
So after reviewing these papers, what you have concluded or how you will move on to the next step?
Basically, I find out here, sir, that diffusion model, uh, we move to from generative GAN model to diffusion model because diffusion model work on the both side, forward side or backward side. It generate images and videos like इंक्लूड नॉइस और देन डिनॉइस मीन्स इस पूरे मॉडल में डिफ्यूजन मॉडल में जब ये क्रिएट करता है न्यू इमेजेस और वीडियो और डेटा टेक्स्ट में भी, तो ये दोनों रिवर्स प्रोसेस करके देखता है। इसको पता रहता है कि नॉइजिंग कैसे ऐड करनी है और डिनॉइजिंग कैसे करनी है।
Okay.
इसके बाद सर एक और आई फाइंड आउट बट आई डिडंट इंक्लूड दैट हाइब्रिड मॉडल आल्सो हियर, लाइक डिफ्यूजन मॉडल को हम गैन से भी अटैच कर सकते हैं और एलएलएम से भी अटैच कर सकते हैं।
That is your prediction only.
यस सर, यस सर, मतलब प्रिडिक्शन, हाँ, जो भी मैंने रीड आउट किया है पेपर से कि हम नेक्स्ट मूव इस पर कर सकते हैं।
Okay, ma'am. Thank you so much, ma'am, for the presentation, and thank
Sir, we also have talked about the future applications, what can be. Many of the research have used the future applications. We finalize some future application that we can include in the future. Like in healthcare, personalized medicines, we can work on that, including diffusion model and GAN. In education, adaptive learning; in finance, automated analysis; in engineering, design automation; and in law, document analysis. These are the fields we can work in the future using the diffusion models. Thank you, sir.
Okay. Thank you very much.
थैंक यू सर।
thank you so much, ma'am.
मैम
And
आई विल शेयर पीपीटी सून।
yeah, thank you. Thank you so much, ma'am and sir. And is there anyone else left with the presentation? Seeing none, we came to the end of this meeting, and I'll share these certificates. Is my screen visible?
No.
नो मैम, ब्लैंक वाइट पेपर।
Okay. Is it visible now?
यस मैम।
Yeah. So thank you so much to the session chairs who have been there throughout the meeting, making this session even more wonderful. So I would like to thank you, the Vijeta Kumawat ma'am, for being there, and I would like you to please share some of the closing remarks.
Thank you so much, ma'am, for inviting me as a session chair for this conference. And all the paper presenters and the researchers doing good job. All the best from my side for your research work. And thank you so much, Aparna ma'am, again for inviting me. And I definitely my best wishes to success of this conference. Thank you.
Thank you so much, ma'am.
Thank you,
And
ma'am.
now I would like to call upon Navneet sir to share some of the closing remarks with us. Thank you so much, sir, for being there throughout the session. I hope so my screen is
Thank you so
visible
much.
for this as well.
Yes, sir. Am I audible now?
Yes, sir.
Thank you so much. Thank you, Aparna, for a nice answering. All the presentations were very good, and the